Alright, in this video I'm going to talk about graphing quadratic functions. I'm going to show you one way to do it. There are many other ways, including using your calculator. But this is a way that works when we have something that's in vertex form, like this, with something x minus something, plus or minus something squared, plus or minus something else. Okay? So when we have it in this version, its form is called vertex form because we can very easily find the vertex. And it's a lot like when we did absolute value equations. The vertex here is going to be 3, 4, right? This supplies the x value, but we have to change the sign. This number outside supplies the y value, and we keep the sign. So the vertex is at 3, 4. So let's say that's going to be 3, 4 right here. Okay. And the axis of symmetry, this AOS stands for axis of symmetry, always runs vertically through the vertex, so it's going to be at x equals 3. And I'm going to draw that on here. I think it's a good idea. You're not going to be able to see that all that well, but that's okay. You'll know it's there. That will comfort you. Okay. Now we will do, what I like to do is just to find one other point on the equation, just to give me a better sense of what it's going to look like. And what I always do is I go 1 to the right of the axis of symmetry, so where x equals 4, and I'll plug that in. So if x equals 4, then y equals 4 minus 3 squared plus 4, which is 5. So there's another point at 4, 5, which is right here. Now the axis of symmetry is called the axis of symmetry because it's symmetrical along that axis. So if there's a point right here, there's a point right on the other side, symmetrical, right here. Now I've got a better idea. I know that it's going to be a parabola, a U-shaped parabola, so it's going to look something like this. And as far as we're concerned, for graphing it, that is all you really need. So there you go. I graphed that quadratic function. Let's look at number 2 here. My vertex is going to be at negative 1. What am I doing there? Negative 1, negative 2. All right? This gives me negative 1. This gives me negative 2. Which means my axis of symmetry is going to be at negative 1. It always runs vertically through the vertex. All right, so negative 1, negative 2. There's my vertex. Here's my axis of symmetry. All right, and I'll find one other point again. So if I go 1 to the right, I can go, that's going to be at x equals 0. So when x equals 0, I'm going to have y equals 0 plus 1 squared minus 2, which is negative 1. So I'll have a point at 0, negative 1, which is right here. And the axis of symmetry tells me that I'll have another point right here, symmetrical, on this side, and then I can just say, okay, it's going to look something like that. Wow, that's pretty terrible, but, you know, that's why I teach math and not art. Okay, so, a little bit better. Well, that's not too bad, is it? Okay. Let's do another one. Vertex. Vertex is going to be at, remember we flipped the sign here, so positive 1. Don't flip that sign. Positive 4, so there's our vertex. Axis of symmetry is at x equals 1 through the vertex. So let's plot that first. Here's 1, 4. Here's my axis of symmetry. Okay. Now, plot 1 point, 1 to the left, or 1 to the right, so that's going to be at x equals 2. So x equals 2, y equals, let's see, negative 2. 2 minus 1 squared plus 4. So y is going to be negative 2 plus 4 is 2. So I'm going to have a point at 2, 2. Where's that? 2, 2, right here. Okay. Makes sense. It's downward facing. Right. Okay, so let's, well, first things first. Here's my symmetrical point on the other side of the axis of symmetry. And so now it looks like I've got a downward facing parabola, and that makes sense because this number here outside the squared part of the function is negative, and so that's going to tell me that the function is going to be downward facing. All right, let's do one more. vertex is going to be at 2, -1. Right? 2, -1. So my axis of symmetry is going to be x equals 2. So here's 2, -1. There's my vertex. There's my axis of symmetry right down through x equals 2. And then one more point. So 1 to the right would be at x equals 3. And you can pick any number. I find it's easiest to just go 1 to the right and work from there. So y equals 3 times 3 minus 2 squared minus 1. One reason I go 1 to the right, that always makes this inside the parentheses here 1, and 1 squared is 1. It's also very easy to multiply by. So y equals 2. So we've got a point at 3, 2. So 3, 2 right here. 3, that means I'm going to have another point right here, right? A symmetrical point right there. And now I've got... Now, there you go. So that's how you can graph quadratic functions. Easy way. Now, there are a million other ways to do it. There's lots of other things that you can do when you're graphing it by hand. But this is how you can graph them when they're in vertex form without using your calculator or anything. All right.